All right, I think we'll get started. Hi everyone, this is Liz Tran from Quasi. I'd like to welcome you to the last but not least webinar for the HydroShare webinar series. Today we have Dan Ames from Brigham Young University, and he will be presenting apps for web-based hydrologic and analysis and modeling in HydroShare. Take it away, Dan.
Okay, thanks Liz, I appreciate it. So hello everybody, and let's go ahead and get started. I've got several things I'd like to talk about on the webinar as kind of the cleanup. I feel like I'm the cleanup hitter for the HydroShare presentations that have happened. I won't be able to cover HydroShare itself in grand detail, but or the modeling components in grand detail, but fortunately you've seen some of those presentations already if you've attended earlier HydroShare webinars, and I believe these are recorded so you can go back and look at them. But these are the things I would like to talk about. Specifically, I'll give a brief introduction to HydroShare, talk about what are web apps in our view through the HydroShare and Thethis perspective. I'll talk a little bit about what is Thethis Platform. That's our web app development environment. I will do some demos, and hopefully all my live demos will just work swimmingly. And then I'm going to give you a few tips and tricks and some hints to basically some direction to get you started building your own web apps and leave some time for question and answers. So, to begin. This is a word cloud from some, basically I've taken a bunch of material from Jeff Horsborough and David Tarbotton's papers on HydroShare, and you can see here that HydroShare is all about data. It's about content. It's about resources that store data and metadata for water, the water domain. There are relationships between data, and the metadata is all very standardized. And so without sort of sitting here and clicking through HydroShare a little bit, hopefully this is a jog your mind opportunity to remember what is HydroShare and what is the purpose of it. I like to call it YouTube for water data. The idea being that I can upload a video to YouTube, and I can tag it with metadata. It's discoverable, commentable. It's got the social components to it. And HydroShare is very much in that same vein, except with a variety of resource types. For this talk, I'd like specifically to focus on apps in HydroShare. And this begs the question, what is a web app? We like to think of a web app as a web-based application that is generally single-purpose, self-explanatory. It doesn't need to have a large user manual to figure out. It should be quite modular. It should be presented in a portal with other web apps. It should be installable and removable, and sort of independently installable and removable from other web apps. And also, and this is an important point, developed independently. And by that I mean that when you think about the apps that are on your iPhone or your Android phone, yeah, sure, a bunch of them are made by Samsung or Google or Apple, but you probably have a lot of apps on your phone or your iPad that were made by third parties, and they can be installed on your device, removed from your device independently of the other ones. If I want to develop a new app for my Android phone, I don't have to have all of the source code to the other apps. In fact, my app doesn't even need to know that other apps exist. It could know that, but it can work quite independently. And that's kind of a cool paradigm when you think about it. And very importantly, my app doesn't need to know, does not need to have access to all of the source code of the host environment. So a good app development environment is going to allow us to develop apps that are developed somewhat like this and following this set of expectations. And by the way, I say single purpose. I mean, many of the apps on your phone do a lot of things, but really the camera app is about taking pictures, and the Dropbox app is about transferring files. Likewise, we think of these water web apps as being single-focused. And so instead of, it's a little bit of a different paradigm from opening up a desktop GIS system where you're trying to accomplish everything that could possibly be happening in GIS, and you have all of these tools available to, and then you might build models or tools on top of that. Instead, we're sort of turning the tables around a little bit and saying, let's have single function, installable modular apps that do one thing and do it well. So this is a view of what that looks like in our world view of web apps in the water resources domain. And you can see here in this screen capture, actually what I'm showing you are largely apps that were developed as part of a course I taught in winter spring semester here at BYU. I usually teach a GIS programming class every winter spring semester, and historically we've used some of my map window spatial desktop applications development tools to do that. This year we took a chance and tried to develop web apps, and here are some of the tools that came out of that activity. These are civil engineering students, seniors and graduate students with some programming experience, but not extensive, and they were able to develop a large number of interesting web apps. I'll do some demonstrations here in a few minutes. But before I do, let me answer this question. What is Thethis Platform? Some of you on the call may have heard this toolkit mentioned previously on other webinars or in other settings. So I'll just give you a brief intro to what is Thethis Platform. It's a web app development platform. In fact, that's what we used in the previous screen to deploy all of those web apps. It was actually created here at BYU with input and help from University of Utah and Utah State University as part of actually University of Wyoming too, as part of the Cyber Infrastructure EPSCoR program from the National Science Foundation over the past several years. This Thethis platform has been launched and now it's part of a community. The community has got a consortium of commercial entities, private businesses, a few government agencies, and universities that are all now working on building apps and building the basic system itself. It's built on existing open source web tools. So if you look at my diagram here on the right-hand side, you see the underlying framework is this system called Django, and this is like the web framework that everything sits on. The Thethis software development toolkit wraps a number of existing open source web tools. For example, many of you have heard of GeoServer, PostGIS, and 52 North. OpenLayers is a nice mapping library. HT-Condor for doing parallel computing. HydroShare and CCAN as data storage. Notice here, HydroShare serves as sort of a plug-in to Thethis apps as a way to store, retrieve data on the web. So, and then of course when we're talking about this from HydroShare point of view, we think of Thethis as a support to HydroShare as providing an app environment. So the point here is that you could grab all of these software packages and build a custom website that uses these packages to do something fantastic, and then you could do it again and again and again, and you could wire it all up with Django. What we've tried to do in this Thethis environment is to do a lot of the wiring for you. And I say for you, I'm really saying for me, because I don't like starting new websites over and over and over and over again. There's something kind of magical about going to an environment like this, just focusing on the engineering problem, the science problem, the water problem, and letting the website and technology kind of take care of itself. So this is meant to satisfy that need for you and me. Focus specifically on water resources web apps. You can see we think of water resources web apps as requiring databases and requiring map servers and requiring map visualization, as requiring back-end computational capabilities and parallel computing and cloud computing. Now, you might say, well, how is this different than the needs of the agricultural modeling world or the ecological development world? I guess it's not that different, but it is specifically, for our purposes, focused on water web apps. And I suppose it won't be long before we see people using this platform in other domains. And the back end of the whole thing, we have Python. And Python is important, even though we don't have a picture of a snake down here. But at the back end, Python is the programming language that powers Django. And what this means is that the database back-end work is all written in Python. And that's pretty cool because then if you're somebody who's already done Python programming, for example, in Quantum GIS or an ArcMap, then you'd be quite comfortable building your back-end database logic, your analytical tools in Python. That's another, that was a strategic decision for Thethis, was to use Python for that back-end so that we could attract people from the science and engineering community that are already very comfortable using Python. For the front end, we just use the language of the web, which of course is HTML and JavaScript. So we try to have lighter weight front ends and put most of the heavy lifting in the back end in Python. I guess that would be the sort of taking advantage of Thethis would be to design your application that way. So I'm showing you here the URL for the community for Thethis Platform. It's at www.thethisplatform.org. And here you will find a number of useful things, such as information about what is the system, but also you'll find links to the source code for Thethis Platform on GitHub. And you'll find that all of the custom code of Thethis is sitting here on this GitHub repository. And then there are links to all of the additional packages that we use, such as 52 North and OpenLayers, for example. They have their own repositories. So all the source code is here. You don't have to send an email to somebody and ask permission to download the source code. Personally, between you and me and the telephone, I don't believe that's like true open source paradigm when, software code available on request if I think you have a good enough reason to use it. So I've been pretty adamant that all of these things, just like HydroShare itself, stay quite fully open source. You can go to GitHub today and retrieve the code. We don't even have to know. Equally cool to have the source code being readily available, and perhaps quite novel, is the fact there's pretty good documentation for Thethis Platform, hence the exclamation point in my slide there. It's not a typical case to find good programmers who also like to write documentation. I think you know that, and I know that, but we were fortunate that several of the team that were developing Thethis Platform also had a knack for writing documentation. So there's very good documentation here with good tutorials. You'll notice right here on the left on the screen, installation, instructions, tutorials, source code links, discussion, etc. It's all here at this URL. This is all hosted on a Read the Docs website, so it's also standardized documentation. So now that you know a little bit about what is Thethis Platform, a little bit about our idea of what is a web app, and you've hopefully seen something about the HydroShare architecture previously, let me share with you our view of the HydroShare web apps architecture. Now you have to follow me close on this. On the bottom left of the screen we have the whole HydroShare system. This includes iRods for the distributed file management. This includes its instance of Django and all of the back-end code that drives the file sharing, and includes all of the Dublin Core metadata management and the user management. All of that's there in this box called HydroShare. Now sitting on top of HydroShare, we've created a web app resource type. Now remember that HydroShare supports multiple resource types, such as essentially a shapefile, or a database, or a time series, or an image, or a raster. Each of those is a unique resource type in HydroShare, and HydroShare then becomes a catalog of all of the data stored in HydroShare using those resource types. Well, it came time to create a catalog of our web apps, and the natural solution was to create a web app resource type. You can think of this web app resource type as being like a file card in an old-timey library with a card catalog from the last century. You go to the library and you open the card catalog and you slide the drawer up and pull out a card. And so we have cards here, 1, 2, and 3, that represent the metadata for 3 different web apps, all stored using the web app resource type in HydroShare. Now this isn't the web app itself. These 3 white boxes on the left, these are literally just the library card catalog cards for those web apps. They have a lot of metadata in them. They have all of the standard HydroShare metadata because they're standard HydroShare resources, so that includes some basic metadata, I'll show you here in a moment, but it also includes a little bit of extended metadata. Each one of these card catalog cards, library catalog cards, look up and point to existing web apps on the web. Now this is the actual instance of the web app running at a URL somewhere on the web. Here I've got two of them, web app number 1 and number 2. These two happen to be deployed using the Thethis Platform, and HydroShare plays very nicely with Thethis Platform, exchanging login information and whatnot. But the architecture for HydroShare web apps also allows deployment of third-party web apps that are not built on Thethis Platform, and that's represented in this yellow box here. So as long as that web app can communicate nicely with our card catalog in HydroShare, then we can interact with that web app as well. So these little catalogs tell you where on the shelf to go find the app, and we've got 2 apps sitting in the Thethis library, but there could be apps down the street at another library, and we can run those too. Now this orange box in the bottom middle is very important. This is the HydroShare Python REST API. This is basically a communication portal into HydroShare that allows us to get data out of HydroShare into the app and then push data back into HydroShare from the app. So let's blow up a little bit here the web app card catalog card and see what we're storing on that card. But we don't use Dewey Decimal System, but we do store things like the HydroShare base metadata. That includes the app title, the abstract for that app, authors, keywords, and a lot of additional information that is part of every resource in HydroShare. We also have extended metadata for this particular resource type. In other words, the little note card is a little bit longer for a web app. It includes some other information such as the URL to launch the web app, critical piece of information. It also includes what are the supported resource types. In other words, this app knows how to work on shapefiles, or does it work on time series data? Does it know how to handle a netcdf file? What other resources in HydroShare does it know how to play nicely with? And we also store a version number and an icon to display in the open with list. I believe in David Tarbotten's HydroShare presentation you saw him use the open with button to launch a viewer from a HydroShare resource. How does that guy get populated? It gets populated by this library of web apps that are available and which other resources they're associated with. Digging in just a little bit further on that URL, and this is a really important point, is that the URL inside the web app metadata has an encoding that goes along with it. That encoding tells HydroShare what extra bits of information the web app wants or needs about the resource that's launching it. So for example, if I launch the HydroShare GIS web app from a particular raster data set, then it will launch with this URL, and HydroShare will replace the code at the end, the HS_res ID. It will replace that with the actual resource ID for the raster data I'm looking at. Likewise, here is another non-Thethis web app that launches an OpenDAP viewer for netcdf files. And this web app happens to need the resource ID in this location in the URL. It could be anywhere in the URL. That's up to the web app. So it happens to need it here. So we define the URL as follows with the code embedded in the middle of it. When HydroShare launches this web app, it'll replace this code with the actual resource ID for that resource that you're looking at that moment. And a final example here is for SWOTShare. And for SWOTShare web app, they have quite a long URL, ... quite a lengthy verbose URL to get you into the SWOT sharing component that they want you to be at. And somewhere in there, they need to know, well, what's the resource ID? And also, they want to know who's the user that's launching this. Well, we can pass in the HS username. And one that's not shown here is the HS resource type. We can also give the resource type of the resource that you're sitting at when you launch that web app. Okay, so any of you that have developed a web page before, you know that you can make a URL for your web page, that you can capture some request parameters on the end, and so one of those could be the resource ID or the username of the user using your web app. Hopefully that makes sense. Let me do a couple of quick demos of some simple web apps. Some of you may have seen this one before. This is one that we call Canned Geisha. Geisha is a distributed hydrologic water runoff model. One of our graduate PhD students here at BYU about a year ago now built a web app for Geisha. Now the idea wasn't to be able to completely simulate Geisha. In fact, it takes quite a while to run on this one watershed here. And so what this student did was he ran it numerous times, several thousands of times on a supercomputer. He gathered all of the results from the simulations and put them in a database. And then all this web app does is hits that database and shows the resulting hydrographs. For example, if we have an increased rain duration and increased rain intensity, then what would the output hydrograph look like? You can see that on the bottom right-hand side of my screen. Also, hopefully on the top right-hand side, you see my inputs. Let's try again. I'm going to increase the rainfall intensity a little bit more. This is the expected hydrograph. Now that hydrograph is based on my inputs in yellow and the best match from the database in green with this spider graph. You can also see something happening on the map here. If you look closely, you'll see some flooding extent from some pre-calculated flood mapping. So that's a convenient little web app, single purpose. It's for running Geisha in this particular watershed and examining potential flood extent. Another example is the Snow Inspector. Snow Inspector comes from another one of our PhD students here who was doing some work on MODIS snow cover data sets. And here's the apps.hydroshare.org portal. We have several apps sitting in this portal. Canned Geisha, by the way, I intended to show you, is actually sitting in a different portal at thethis.byu.edu. So here we have a different portal. This is the HydroShare one. And the HydroShare portal has Snow Inspector. I'll click it here and we'll bring it up. And what Snow Inspector is going to do is allow me to zoom anywhere in the globe and drop a dot on the map. So I'll go to Northern Europe and we'll put a dot in the Czech Republic and we'll request the last 200 days of snow and send our request. And what this app is doing is reaching out to the NASA Snow and Ice Data Center MODIS percent fractional snow cover data set and pulling down tiled images of that data set. And at each tile, we can look at the value of the pixel where we're sitting and retrieve the fraction snow coverage at that location. So you can see in the Czech Republic, there was not a whole lot of snow, but if you go back to January, there was almost 40% snow at this pixel. If I move my mouse across these points here, you'll see a little pop-up window on the left-hand side, or a pop-up grid. And that grid represents the individual MODIS pixels and the percent snow cover inside each one. So where I'm at in the middle of this, you can see there was 38%, but if you move north, further north up there, it gets more snow, 65, 71%. One cool thing about this app is that we can actually retrieve a WaterML file for that data set. And what we're doing when we do that is we generate a REST-like URL up here at the top in my browser that will always retrieve that data set. And in fact, if you want a time series in WaterML of snow anywhere in the world, you can use that same URL pattern that I just showed and just replace the latitude and the longitude and the start date and the end date, and it will retrieve it without even using the app. Another cool feature of this tool is that we're using that API to upload the data set to HydroShare. So I'm going to create a reference time series in HydroShare, and I've got some default information here, such as I'm a MODIS snow cover. The title is going to be MODIS snow cover at this location. It's a reference time series type and a pre-filled abstract. We can change the abstract. We can make this public. Before I do that, we'll just double check and make sure that my www.hydroshare.org account is logged in. I was logged in earlier, and I think I just got logged out. So let's log back into HydroShare because we're going to use the credentials from HydroShare to post that. And actually, I would need to reload this app, rerun this, and repost it back to HydroShare. So rather than taking time to do that, I'm going to move to my next demo. This demo is another simple app. Some of you may be familiar with the EPA Waters Web Services that have been up and running for several years by EPA. This tool is a simple web app to demonstrate some of the functionality of that EPA Waters Web Services. And we can get it also from the HydroShare website. Here's what hydroshare.org. If I click on apps, we'll get a listing of all of those apps, and I'll run to the EPA Waters Network web apps. Now I know that I'm also logged in here, which is quite convenient. So in this app, we'll take advantage of the Google location search, and I'll look for the Hobble Creek in Springville, Utah. And what happened here was we used the reverse lookup from Google to find Hobble Creek here. And that looks exactly where I want. In fact, if I zoom in a little bit, you'll see that Google put my yellow dot right here, but I used now the EPA Waters Web Services to find the closest COM ID to the closest NHD stream segment. And it happens to be this one here, running up Hobble Creek Canyon, just up the road from my house. So I'm going to choose one of the EPA Water Services. I'll actually do the delineate watershed on it. And we're again calling the EPA Waters Web Services, saying, hey, we've got this COM ID. Will you please aggregate an upstream watershed for me based on that? And that's what just happened here. So again, Thethis app. Most of this environment was already came to us from Thethis, and I was able to just focus on developing this tool. And we can download these results as KML files to open up in Google Earth. You can see I downloaded the basin and the streams, or we can upload them to HydroShare. Now, unfortunately, right at this exact moment, HydroShare does not support KML in the geographic feature, so we're working on adding KML to the geographic feature resource type. But for now, I can just upload it as a generic. So this is watershed and stream network, Hobble Creek, Utah. And we'll take those keywords and hit proceed. And at this point, we're using that API of HydroShare to pass this data into HydroShare to create a new resource of this data set. And it was successfully created. I'll click this button and actually look at it, see how it looks inside HydroShare. Here it is, Watershed and Stream Network, Hobble Creek, Utah, created by and owned by Dan Ames. When it was created, we can download those files here. Some of you might want to try using these files for some purpose, find them to be outstanding, and provide a comment to that effect at this point. Also, once we support KML inside HydroShare GIS, we'll be able to launch it here, which we cannot do at this exact moment. I'd like to jump to this. My mouse is rolling here. I'd like to jump to this app. This is the Quasi Time Series Viewer. And in this case, what we did is we have the Quasi Water Data Center, which has developed a tool for searching for water data all over the world. Some of you may remember a Hydro Desktop workshop I gave a year and a half ago on the same webinar series. Now, you don't need to download and install Hydro Desktop in order to search data on the Water Data Catalog. You can just go to data.quasi.org and do it directly through the web. So we might, for example, zoom into an area and search for, search the map for data in a map-based region of 3,000 square kilometers. And then the search will come back and allow us to retrieve some of the time series data. And then we can use a web app to actually view the data. So rather than going through all of those steps, since we're focused on web apps, I will show you, like, sort of take the baked cake out of the oven and just click directly on this link, which is a Quasi Water Data Center time series data set. Now, I just loaded this a couple of days ago, so hopefully it's still sitting in my cache at the Water Data Center, and it is. It's in my workbench at the Water Data Center, so I was able to use this web app to view it. And you might be saying, well, that doesn't look like a Thethis web app. It is. It's just really simple with a big graph and a chart in the middle, but it's actually running on apps.hydroshare.org. So not every web app you build has to look exactly like every other web app. Okay, the final web app I want to demo is HydroShare GIS. Quite enthusiastic about this one as sort of a catch-all mashup data viewer for HydroShare. And if we go back, the best way to demo this one is to go back to HydroShare itself, which I'm doing right here. And I'll go to Discover. And let's see, I'll find a data set here from Utah. And it looks like we've got the polygons of Utah counties. We'll take a look at that data set. And we can see if we zoom here, or scroll down a little bit, the various apps that are associated with it. Actually, this is the wrong one. There's another Utah counties polygon I want. This one, I can't use it because it's a generic. So let's only show geographic features here. So I'm going to filter to geographic features. This is the one. It's actually the same data set, but Drew Lee republished it as a set of polygons, a feature type rather than as a generic type. Since it's a feature type instead of generic type, we can see some additional information in HydroShare, such as the location of it, this box. We can also see resources it's related to. We know that it's derived from the one that I showed you a moment ago. And importantly for this demo, we can see that it is openable with 3 different web apps. We can get that down there. We can stay at the top and use the simple Open With button. I'm going to open it with HydroShare GIS. Okay, so that's not particularly astounding that I can show a map. Kind of cool, but not earth-shattering. Let's turn on a base map, and let's change the symbology just a little bit for this guy. The fill color, we'll set it to be, we'll keep it gray, but make it partly transparent, and we'll give it a nice brighter line color. Okay, so a little better. Sorry, I meant to hit apply. A little better. This is more GIS-like. If you can actually do a little bit of symbology. Go back to my red symbology here and some thicker lines and apply that. We can also put some labels in there using the symbology and include labels. Let's use the county name, 8-point font, sure. All right, so I like this map that we're creating, but I might want to add some more data to the map. Another way to work on these HydroShare GIS maps is to click this button, Add HydroShare Resource. So I would like to add to this thing something from Logan, Utah. Let's see what we can find. Looks like I've got a Logan geographic feature of a stream network. We'll take that guy and add it. And so you can see the stream network here for the Logan River, and we might also want to see some of the actual DEM itself. So I could do add resource and add the Logan DEM, see what that looks like. So what's happening on the back end here is this is all GeoServer. All the data are being fed into GeoServer, which is then hosting each layer as a web map service, and then we're interacting with them in open layers. I'm going to move this guy down to the bottom. So I've done a beautiful map, and I want to save it, so I will click Save As, and I'm going to, where are we saving it? I think you're kind of getting the idea now, right, of how HydroShare works. Where we save something, we save it as a HydroShare resource. Map, mashup, Logan, Utah, and river. And I'll put in here the river and counties. Keys, map, mashup for my keywords. Save. So what we're saving now is not actually the individual data sets, because they're already in HydroShare. but just like a desktop GIS does, we're saving a project file. This is a project file for this map that we just created. I'll click and look and see if we were able to successfully create it. And there it is. There's the resource map mashup for Logan, Utah River. And we can see the members of it is literally just the project file. It's a JSON file which has the text that describes all of the data sets that are part of this map mashup. And importantly, we can then reopen it with HydroShare GIS. As it's opening, I want to point out something here. If you like this app or you see anything in here useful, we put a direct link to the GitHub code for this app on the splash screen, so you can click View Code. So there's my map, and it's got all the elements set up the way we want. Now this is a work in progress, but it's usable and it's up and running now, so please use it and try it out. And if you have any suggestions on things we can add to this app, let me know. All right, so jumping back to presentation mode, we just showed you HydroShare GIS. Let's say you want to build your own web app. How will you do that? That is a great question. There are a lot of ways to do it. As I said, you could build your entire own website, do everything from scratch. If you would like to use the Thethis app building environment that I've shown, and all of these apps I've shown are from Thethis app, including Thethis Platform, including this set of apps from my students this spring. What you can do is follow the approach we use, which is run everything inside VirtualBox. We use Oracle's VirtualBox development environment and Ubuntu for our app development. If that makes you nervous, don't be nervous. I had 20 civil engineering students, 19 of whom who had never touched Ubuntu, 17 of whom who had never seen or used Linux ever, and all of whom had had some basic programming but hadn't played in this environment. So don't worry, because within 6 weeks of meeting a couple times a week, they were all building apps, and you can even do it faster if you just follow the demos. So what we have here for you is a link to download VirtualBox, and you can download VirtualBox for your computer. Another nice thing about working in a virtual environment is you can do it on your Mac or your PC or your Linux, and you know that you're doing the same exact stuff inside that virtual machine. It doesn't matter what the host machine is like. And then, once you've got VirtualBox installed, you might go so far as to download and install our pre-built Ubuntu image with the Thethis development environment pre-installed. I am giving you the link to my FTP site as well as a public password username where you can go and download this image, Ubuntu Thethis May 2016.ova. So if you want to write that down, feel free. Sometimes it chokes if you try to download it through a web browser. I actually connect to this through prefer to connect to it through an FTP client, like, pick your FTP client, doesn't matter. So use FTP client, go to my website, hydromap.com, and then log in as share, and the password is share10, and you go find this image under Thethis Ubuntu. This is a 6 gigabyte image. You can download the whole thing. Well, you have to download the whole thing. And then you double-click that image, and it will pull it open inside your VirtualBox. And in fact, when it pulls open, it looks something like this. So it's pre-installed with Ubuntu, and it's got Firefox browser. It's pre-installed with PyCharm Community Edition, and that's because we are all in the HydroShare team using PyCharm for our development environment, so you should as well, unless you want to program in Notepad or TextEdit or something else. And it's got the full Thethis developer environment installed and ready to go. So I'm moving on off this slide, and you can come back to it through the video recording, or email me if you want this information. Once you've launched the Ubuntu virtual machine, you can explore Ubuntu. If you're not familiar with it, you will find that it is basically a computer with a web browser and a file browser, and there's nothing particularly magic about Ubuntu versus PC versus Mac. You will find most of our team members on one or all of those 3 environments on any given day because they're just computers, right? So once you're in there, we can start the terminal, and you'll notice the terminal is docked on the toolbar here. This terminal will ring up a command line, You can start right away, immediately start the Thethis server. I've given you the commands here to start the Thethis server. You will find that these commands are taken directly from a tutorial off the Thethis Platform website. So don't feel like you have to actually write these down right now. You can see there are 3 commands to launch a set of Dockers that have the Thethis components and start the server. The cool thing about this is this actually starts up 52 North. It starts up GeoServer, and it sort of gets you up and ready to run. So within just a few moments of installing the VirtualBox and mounting that image and typing those few commands I showed, we have a running Thethis portal on our local computer right here. And you can see how it looks by browsing to your local host at port 8000, and this should pop up. Now, it won't look exactly like mine because I got tired of looking at all of these blue Thethis portals and cute little Thethis portal icons, decided to customize mine myself. You will see that when you create your portal, you can click this hamburger icon on the top right-hand side and log in as username student, password pass. This is on your computer. It's on your virtual image of Thethis. And you can run in and set up some site administrator settings. All I did was I went to the site admin page, changed the colors, changed the icon, and this is all done through an interactive page that you can edit there. Now that we've got a portal, I notice there are no apps in my portal. I need an app in there. So we'll stop the server by going back to the console and typing Control-C. We'll make a directory. We will, for our new app, then we'll run one command right here, Thethis scaffold my first app. And with this one command, it's going to set up a blank, ready-to-go app. And actually, when you run this command, it's going to give you a bunch of prompts, like, what is the name for your app? What is who are you? What is your email address? What's your name? Information that you might want to supply about that app so that your users know who created it and why. Then it will build this scaffold for your app. And your first app is this blank app. I called mine my first app. It actually won't appear in my library until I run a little setup script. So you'll run a few more commands to run the setup script to install your app. And now I can open and refresh my browser. And here's my library again with one app sitting there. That app, actually, if you run it, it does nothing. But it's cool. It gives you a framework. In fact, when you run it, I think it looks something like, it's sort of like this. It's going to have a map. I think it does have the map already built in, and it's got some buttons, but they're all just like button 1, 2, 3, 4, 5. It's got a, it says my first app up across the top. I should have shown you a screenshot of what that looks like. But that gives you something to go explore and find out on your own. So you'll get your My First App, and you can run it, and it'll do whatever the default thing does. Now, we probably want to edit the actual content of the app. So we do that in PyCharm. You can go to PyCharm, and here's the folder where your app is sitting. Quite deep. You'll go to your My First App folder, and you'll find the code, and you'll start with the base.html and home.html, and then you'll start editing some of the Python controllers and really make your app do something awesome. Now, I can't show you all that right now, obviously, and I don't intend to, and it's not useful, but you can see everything that I just showed you by going to the documentation. As I said quite enthusiastically earlier, at thethisplatform.org, you will find pretty decent documentation and tutorials that look like this. Most of what I just showed you as far as starting your first app and the scaffold and customizing some things is in this tutorial. Create a new Thethis app project, the first one. What's not in there is, hey, go to Dan Ames' personal server and download a 6 GB image of that sort of gets you all set up and ready to go. Please feel free to do that, all of you that are on this call. I hope you will, because honestly, it's a lot more fun just to, within 5 or 6 minutes, be up and running with an app rather than sitting there forever installing 52 North and some of the other back-end pieces. The information to do that is available here, but feel free to use the virtual box image that we already created. Once you've done your tutorial, what are you going to do with your app? Well, here's a suggestion. Why don't you share your app? Join the HydroShare team. By share your app, what I mean is, once you've created it and you've posted all your code up on GitHub, on your own GitHub repository, feel free to send me or somebody else on the HydroShare team the link to your GitHub repository, and we will happily deploy your app on the developer environment of HydroShare, or one of our many test environments for apps, where you can see how it runs in real time, how it looks on the web, and if it's a cool one, then we could even consider putting it on the official HydroShare apps repository. So it'll appear there alongside the other ones. Obviously, if you create your own website and your own web app elsewhere, you could also link that into HydroShare very easily using the architecture I showed. But if you want your app to actually be hosted on our server, then you can do it. And somebody in this picture, one of these lovely people, will happily work with you to make that happen. And hopefully this team picture will grow as more and more people contribute data and apps to HydroShare. And that's the end of my formal presentation. Thank you very much for listening.
All right, do we have any questions for Dan? Any more questions? Just type into the chat box if you can.
I see two questions here. Okay, so first question is from Juliet. How does HydroShare interact with integrated groundwater surface water models like ModFlow? Hey, that's a pretty cool question, actually, very timely. You may, Juliet, I don't know if you know Norm Jones at BYU. He was instrumental in the Arc Hydro groundwater book and module. He does a lot of groundwater things. He is actually actively involved right now in building links to between ModFlow and HydroShare. So ultimately what will happen, I think, is that you'll have a ModFlow model program and a ModFlow model configuration that can live as types inside HydroShare, and one could upload and download ModFlow models all day long, share them. I don't know that there is at this exact moment like a fully functioning or a working way to actually execute a ModFlow model on the HydroShare server. So right now it'll be about sharing the ModFlow inputs and output files. But if you're interested in that, contact Norm Jones at BYU. I bet he can talk to you more about that. Cool. So yeah, David Tarbotton says HydroShare can store the files for application of ModFlow at a specific location. So David's got some ideas about that too, and you're all welcome to discuss. Also, John Goodall is involved in that. Awesome. Yep, and Norm has posted his email address online. Great. Other questions or thoughts about this app development framework environment? By the way, the title of the paper that is presenting Thethis to the world, at least one version of the title, says Lowering the Bar for Water Resources Web App Development. And this is a paper that was just accepted to Environmental Modeling and Software, and the title is still a little bit in transition, but I like that phrase, lowering the bar, because for me, as a water resources engineer first and a kind of a hydroinformatics guy second, I like lowering the bar. I like the fact that these sort of web apps can be spun up, and having HydroShare sitting there so that I can push data in and out of HydroShare and using that as the back end makes all the difference. It's great. So I'll just stop talking for a moment in case there are any other final questions. Liz, I think we're done. I think the West Coast wants to go to lunch and the East Coast is thinking about going home.
That is true. All right. Wait, hold on. Oh, Yes, someone's typing, but never mind. All right. Well, that is the end of the HydroShare webinar series. I hope you guys enjoyed all the webinars if you could attend all of them. And yeah, we will end this. Have a good day, everyone.
Okay. Thank you, everybody. Thank you, Liz, and thanks to Quasi. I know.